Most people think of the sun as background, a giant light in the sky that rises, warms the planet, and disappears at night. But the sun is not background, it is an active star. And when that star turns violent, the danger does not arrive as fire in the streets. It arrives as invisible disruption, radio noise, navigation drift, satellite stress, power instability, timing failures that begin in space and spread into systems modern life quietly depends on every hour. That is why a major solar storm is not just a science story, it is an infrastructure story. The moment civilization depends on satellites, synchronized networks, long-range aviation, and constant digital timing, it is also depending on the electromagnetic environment around Earth. A solar storm is what happens when that environment turns hostile. NOAA's Space Weather Prediction Center has repeatedly warned that geomagnetic storms can disrupt power systems, spacecraft operations, radio communication, and navigation signals. That list alone should change how we think about the risk. This is not just about pretty auroras, it is about the hidden layer above the economy, the layer that helps aircraft communicate, helps ships navigate, helps networks keep accurate timing, and helps satellites keep working without frying themselves during radiation and charging events. And this is not theoretical. In January 2026, NOAA reported a severe solar radiation storm strong enough to produce high-frequency radio blackouts across large sunlit regions over the Pacific. That is the real lesson of space weather. The sun does not need to end civilization to create disruption. It only needs to strike the right systems at the wrong moment. Flights reroute, communication degrades, satellites enter safe mode. Operators make decisions under pressure. A crisis does not need movie-level destruction to become expensive. The most dangerous version of this threat usually begins with a coronal mass ejection, a giant cloud of solar plasma and magnetic energy blasting outward from the sun. If Earth sits in the path, the planet's magnetic field takes the hit. That impact can drive currents through long conductors on the ground, distort the upper atmosphere, and shake systems both in orbit and below it. Power grids are exposed because long transmission lines can absorb geomagnetic stress. Satellites are exposed because radiation and charging events can damage electronics or force protective shutdowns. GPS is exposed because a disturbed ionosphere can bend or delay signals in ways precision systems do not like. That is what makes the modern version of a solar storm so different from the historical version. In 1859, the Carrington event lit the sky and disrupted telegraph systems. Today, a similar disturbance would collide with a civilization built on orbital infrastructure, machine timing, and non-stop data exchange. We have better forecasting than the 19th century, but we also have far more to lose, better warning, bigger dependence. That is the trade. There is another uncomfortable detail here. The final warning window for the worst impact is not always generous. Scientists can watch eruptions leave the sun, but the most actionable measurements often come from spacecraft positioned between the sun and Earth. By that stage, operators may be thinking in tens of minutes, not relaxed days. That is enough time to trigger some protective actions. It is not enough time to casually rewire a civilization. So resilience depends on what was prepared long before the storm arrives. This is why the next great solar storm would feel so strange to live through. The damage would be uneven. Some people might see headlines and bright skies. Others could see communication outages, navigation problems, rerouted flights, stressed grids, or disabled satellites. The first phase would probably be confusion because modern systems fail in fragments. One signal drifts, one backup takes over, one route shuts down, another gets crowded. The event spreads not as one cinematic collapse, but as a chain of technical compromises. And chains of compromise are exactly how complex systems become fragile. That is why solar storms deserve more respect than they usually get. The sun is always active to some degree, and Solar Cycle 25 has reminded the world that the quiet sky can become noisy fast. The real question is not whether space weather exists. It is whether a civilization built on invisible signals has prepared for the day the sun becomes aggressive enough to expose its weakest assumptions, how much redundancy exists, how quickly operators can react, how many systems fail gracefully, and how many fail together. A major solar storm would not look like war or an earthquake or a hurricane. That is exactly why it is dangerous. It attacks through dependence. Through the systems we stop noticing because they normally work. The modern world feels solid because its invisible layers usually stay aligned. But if the sun knocks those layers out of alignment, even briefly, we discover how much of daily life is held together by signals we cannot see. And that may be the real lesson. The next infrastructure shock may not rise from the ground. It may come from 93 million miles away. Not because the sun changed what it is, but because we changed what we depend on. We built a civilization that reaches into the sky, so when the sky misbehaves, the damage no longer stays in space, it comes home.